Hello.
Hey, good morning.
Good morning.
All right.
We are, I believe we are in the middle of a pull request to get the captions added to our live stream page. So
I think that's the case, yes.
we will, please bear with us for just another moment. Actually, Cindy, our wonderful live streamer from Confreaks, would you mind popping the timer back on for another 5 minutes? And we will get started.
Yeah, there we go. Yeah, that's the way to do it.
Okay.
As usual, we're very organized and great at logistics.
Yep. A timely Bang Bang Con start.
Yes. Well, we promise not to say anything important until we have our captions online.
Okay, we do have captions. I see things happening there.
Oh, hard refresh.
We don't. No. I see things in the stream text. But
okay.
The live stream. Yeah, I think Julia is still doing push things.
Okay. Well,
that's the international motion for git push.
This is git push. Yeah.
Yeah.
Go, Julia, go.
We'll remove this in post. Oh, sorry.
I think GitHub just needs a minute.
Hey, look at that. Wait a second. There's live captioning, but there's still only the blank video placeholder.
There we go. I see it. Try hard refreshing.
Hard refreshing. Oh yeah. Look at that.
Okay.
Oh,
it's me and us. Look. Okay. All right. Cool.
Okay. Let's let people join and all that kind of stuff. So I guess we can keep the timer.
All right. Yeah, we will get started in 3 minutes and
that sounds great.
All right, great. Whew.
Does anyone know any good jokes?
I would tell you a UDP joke, but you might not get it.
Up.
Do you want to hear a TCP joke?
Sure.
Okay, well, I'm going to tell you a TCP joke, okay?
Tell me a TCP joke, Erdy.
All right, well, you have to acknowledge that I'm going to tell you a TCP joke, all right?
Okay,
Erdy, you were going to tell me a TCP joke.
Oh, great. All right, the TCP joke will be about 2 minutes long.
Okay, go ahead.
Okay, and it's going to be, the punchline's going to be funny.
Ack.
That's the entire TCP joke. Connection dropped.
Hey, I give up on the joke, Erdy.
Oh my gosh. Yeah, Bang Bang Con. Come for the talk, stay for the TCP jokes. I don't know any DNS jokes. Anyone know any?
The DNS jokes are, they'll be here in like 8 to 24 hours or so.
But after that, they'll be there right away, as long as they don't change.
Yeah.
Right.
Great. Let's see. All right. Well, nobody's complaining yet on Twitter, so I think we're still okay. I think we're still okay. All right. Gosh.
I have a joke about non-constructive logics.
Ack.
I thought you were about to tell me that you don't not have a joke about non-constructive logic.
Also true. Yeah.
Okay.
What's the joke about non-constructive logic? Or have I already missed it? Because I don't understand.
You missed it.
Okay. I see. All right. I don't... Something just went over my head and I'm like still trying to catch up on.
We could explain it. This is not a joke that works less well when it is explained.
Okay. All right, please.
Probably because it doesn't really work to begin with.
It's a pretty terrible joke.
It is
1 minute. So.
Okay. The thing with which it's been 10 years. Which way is which? It's constructive logic. It is not the non-constructive logic. It is the case that not something is the same as something. Like if I tell you that Bang Bang Con is not about to start in 54 seconds.
Okay.
Then that is the same as telling you that it is about to start in 54 seconds.
Okay.
But in the constructive logic world, the law of the excluded middle, which can derive the not a implies a thing. Like they don't allow this thing.
Okay.
And I don't know, and I can't remember why you would want one or the other. That's the thing that I learned the difference, but
Lindsay, can you enlighten me in the next 25 seconds?
Yeah, it's like so my joke was about how in non-constructive logics, you don't necessarily have to provide evidence for why something is true. So, for example, I can say I have a joke about non-constructive logic, but I don't have to tell you what the joke is.
I see. Okay.
Nice. I really wanted to just jump on and say I'm the TCP and UDP jokes. I'm really connecting with those.
I see.
yep.
Yeah. And
Oh,
I
we're
appreciate
live.
how we're all like
We're live.
networking right here.
Yes. Oh.
Okay,
yes. What
I
an
think it's
excellent-
time. I think it's
All right.
time.
All right, I'm gonna start actually talking. Hello, welcome to Bang Bang Con 2021, virtual edition number 2. Yeah, gosh, I'm so excited. Thank you all for joining us today. I want to talk about a little bit of logistics before we get into our first keynote, and I also want to make sure that everybody is connected to us in the correct ways via TCP, UDP, etc. So great. Let's talk about the format and the schedule. I just want to point everybody to bangbangcon.com/program. And on there is our program for the week. The thing that I really just want to talk about, because it's something new that we're trying, is this idea of a sync watch. So what we're going to be doing is broadcasting our sessions throughout the week. And these will be live like this is right now. The speakers will give their talks. It'll be great. We'll be recording the entire session and also, of course, streaming it on YouTube, available to the public. You don't need to have a ticket to watch that. And then we will be rebroadcasting those recordings about 12 to 24 hours later to make sure that it is time zone friendly for everybody. And the idea with a sync watch is that we're going to premiere it on YouTube. So it'll be a kind of live rebroadcast of the live event. And we will all, for those of you who have tickets, we will be on Discord in the Bang Bang Con chat, and we'll be able to hang out and talk about the talks kind of live while they're happening live as a rebroadcast. So that's what a sync watch is. And I just wanted to make sure everyone was aware, just so that you kind of knew when to tune in. So on the schedule, there's session 1, and then sync watch 1 is going to be a rebroadcast of session 1. The keynotes are generally at like pretty time zone friendly times for a lot of people. So we're not going to be rebroadcasting those. But the recordings will be available.
Oh, did everybody lose Erdy or just me?
I lost him too.
Uh-oh. Oh, no.
Oh no. All right. Who wants
Hit it,
to
Lindsay.
take over for Erdy?
I think that's you.
I don't have a script.
Oh, no.
I have a script. If I think that's it. We have live captions on the live stream. Some people are not seeing the live captions. If you should refresh. If you still don't see them, you should refresh even harder, like with the Control-Shift-R to clear your cache. I needed to do that. And next up, we're going to talk about the sponsors. I believe that's you, Joshua.
That's me. I'm talking about sponsors. Okay. So we have we're really lucky to have a lot of sponsors this year. And I'm going to talk about all of these sponsors. I'm going to give you a quick blurb about each of these sponsors and what they're doing and all this sort of stuff. So first off, Xandr, who have graciously supported Bang Bang Con for a couple of years now, their goal is to make advertising better for both brands and consumers. So that's good. I like that better than just making advertising better for brands. Daily are a new supporter this year, and they love Bang Bang Con. We're like, why would you like to sponsor Bang Bang Con? Do you have a hiring goal, or do you have a developer relationship relations goal, and they're like, we just really love Bang Bang Con, and so that's great. They're building a real-time video and audio API with a developer focus. Wherewithal are awesome sponsors this year, and not only are they awesome sponsors this year, they sponsor our famous live open captioning. By the way, our captioning, it is not an AI captioning thing. We have a human who is typing at a keyboard, as we do every year. And we are immensely grateful also to we have a couple of captioners this year. Today is Lydia Perez. And we are immensely grateful to all of our captioners. Yes, but Wherewithal are sponsoring our live captioning. They have an online course to help you demystify management, and they have a discount for Bang Bang Con attendees. So if you go to bangbangcon.com and click on the Wherewithal link, then there is a discount for you. Discourse are building open source and hosted forum software to build like reasonable communities as opposed to unreasonable communities. I think there are a lot of forums that have unreasonable communities. Discourse wants to build the reasonable kind. Full Story are building privacy preserving tools for improving your digital experience on the web. Both, again, this is for companies and also helping consumers. So this is, I like that a lot better on the web and on mobile. And they're especially looking to hire a systems software engineer to continue to build out their mobile platform. Two Sigma is another repeat Bang Bang Con sponsor. Thank you so much, Two Sigma. They're hiring engineers, researchers, data scientists, and more to support their goal to build a financial science world. Let's see. Phase Zero are providing complete solutions for design and development services in the Middle East. And so that's interesting because they're building an entirely local software engineering team for that region. So that's great. Mapbox supporters of Bang Bang Con in the West in years past are providing customizable maps and location service APIs, and I love their new apps in Strava. It's really cool. I use Strava all the time, and so they're using Mapbox. I think it's really cool. And finally, Accelerated Tech, hey, that's me, are bringing expert knowledge to help you solve your low-level systems engineering challenges. So anyway, if you're from our sponsors, please feel free to wave in Discord. Thank you so much for your support. Bang Bang Con, even though we're online, it's actually quite expensive to run. And we're committed to paying all of our speakers and all of the folks who are doing work for us. And so that's fantastic. And thank you so much for your support for the sponsors. Who's talking next?
I have.
Oh, go ahead, Rudy.
Two little things to finish up, unless somebody said them while my computer had blue screened. Okay, I will say them. Cool. Thank you, Joshua. So, two last notes. One, if you bought a ticket, make sure that you get access to Discord, and also make sure that you get your free T-shirt or sweater. You should not have to pay anything or even put in a credit card when you go to the T-shirt site if the code is working. And if it isn't, reach out to an organizer. And finally, we also want to make sure that everybody knows that if you are or are not a ticketed Bang Bang Con attendee, please feel free to get in touch with us via Twitter at Bang Bang Con, or also via email. You can email, I probably should have made a slide for this, but I didn't, 2021-organizers@exclamation.foundation. I'll put that on a slide and put that up later. And that will go to the organizers. So if you have any questions, you can't get access to the Discord, for example, and you did buy a ticket, please email us and we'll get back to you as soon as we can. So again, that's 2021-organizers@exclamation.foundation. And yes, back to you, Joshua, to talk about our code of conduct.
Ooh, okay. All right. I'm super excited about this. So our code of conduct, maybe kind of a word from the board also. Exclamation Foundation is, I think, is now 2 years old and is the holding body organization for all of our Bang Bang Cons. And now that there's Bang Bang Con West and also Bang Bang Con Original Recipe. And so Anyway, one of the so I'm coming to you in my capacity as president of the board of the Exclamation Foundation, but for whatever that means. But one of the things that we've been working on this year on the Exclamation Foundation board is coming up with a new code of conduct. And so previously, the Bang Bang Con Code of Conduct is what I called a Code of Conduct 1.0. And what that said was harassment is bad, which it is, and provided a whole bunch of legalese for all the things that are harassment and what not to do. And that's great. That's important. That's stuff that ought to be. But we think that we can kind of do better. That's kind of the standard now, and I think that we can do better. And so the way we're doing better this year is we're saying, rather than just how not to be Bang Bang Con, to tell you how to, yes, be Bang Bang Con. And so, and of course, it goes without saying that harassment, and there are many ways to be terrible to each other, and please don't do any of them. And for folks who want to go around the lines of the code of conduct, we don't have any, like, you don't have any business here if you're trying to find a way to be bad to somebody and go around the written text of the code of conduct. So anyway, the code of conduct, I think, is a lot friendlier this year. And if you haven't read it yet, I really encourage you to read it. And as kind of a incentive to read it, we have these wonderful illustrations. We hired Annie Rugit to illustrate our code of conduct this year, and I think it is just the most joyful thing on earth. I am so proud of this. Yeah, you know, we worked hard on this, and I don't know, I really love this. So I think so anyway, if you haven't read it, please go read it. And I think and if you run into trouble, I guess I should say this. If you run into trouble, we have your back. Please email that same email address, 2021-organizers@exclamation.foundation. Or I believe there's an anonymous contact link at the bottom of the code of conduct. Oh yeah, look at that. So anyway, I'm actually not going to recap all the ways to be bad to each other because it's not what I want to focus on. And instead, I want to talk about ways to be good to each other. Or actually, I would like to have Julia tell you about ways to be good to each other. Julia?
Yeah. So we're going to talk about one of my favorite set of tips for how to be good to each other, which is the Recurse Center social rules. So these are 4 simple rules about behaviors that a lot of us do. Like these are things that I think I certainly have done some of them. I think all of them probably. I think a lot of us have. And so about things that you can avoid in order to be better at each other. So thing 1 is no well actuallys. So well actually is when someone is like, hey, I just installed Linux. And you're like, actually, it's GNU/Linux. And so, well, actuallys like this don't really serve to, they don't add anything, you know, like this is not really adding to like the experience of installing Linux. And it's really just more about like, oh, I'm so smart. Here's some weird detail that I happen to know, right? It's about the spirit of the thing. The next one is no feigning surprise. So that's like if someone says, what's the command line? And I'm like, oh, you don't know what the command line is? Like, how could this be? What happened to you? And I think the interesting thing about no feigning surprise, and something that I've learned, is to also kind of try to mask some of my actual surprise. Because I might be legitimately surprised that someone doesn't know what the command line is, right? But, like, I don't need to act super surprised, even if I feel a little bit surprised, right? I can just be like, oh yeah, cool. Do you want to talk about that, right? And maybe they don't want to talk about it. And then that's okay, or maybe they do, and then we could talk about it. And so I think it's kind of fun to even be like, pretend to be less surprised than you are. Because acting really surprised when someone doesn't know something doesn't really help them, you know? It just makes them feel bad. It's kind of silly. The next thing, which I think this one is maybe a little bit more of a real life thing, is no backseat driving. Um, where let's say two people are having a conversation, one person's like, "Hey, what's the name of the string copy function?" And then someone else is like, "Oh, it's stir n copy." And then someone else across the room yells like, "No, you should use stir l copy. Never use that." And the problem with this is that you're not really engaging in the conversation, right? The idea is that you just kind of like pop by to like insert your infinite wisdom very briefly and then leave immediately. Um, I think in general, if you're going to be a part of the conversation, it's better to be actually part of the conversation and be like, "Hey, do you mind if I like come join this conversation?" And just instead of just sort of like lobbing your wisdom across the room, because often if you do that, it isn't that helpful. Is the issue. The last social rule is no subtle isms. The example I have here is that someone says, "Windows is hard to use," and maybe I say, "No way, Windows is so easy, even my mom could use it." Which is a kind of sexist because, I mean, I think for obvious reasons. And in all of these cases, I think the best way, the way we suggest replying in the context of Bang Bang Con is if you see something, just being like, "Hey, that was kind of a well actually," and then you can just be like, "Oh yeah, I'm sorry," and then you can move on, right? It can be sort of it doesn't need to be a big deal because a lot of these things are things that we all do. That's all I have to say about social rules. Who is next?
You are.
Oh, it's me. Back to Julia. Okay, great. So that's all the introductory remarks we have. So now I'm super excited to introduce our first keynote speaker, Angie Jones. Angie is a Java champion and senior director who specializes in test automation strategies and techniques. She shares her wealth of knowledge by speaking and teaching at software conferences all over the world, writing tutorials and technical articles on angiejones.tech, and leading the online testing platform, Test Automation University. As a master and mentor, Angie is known for her innovative and out-of-the-box thinking style, which has resulted in more than 25 patented inventions in the US and China. In her spare time, Angie volunteers with Black Girls Code to teach coding workshops to young girls in an effort to attract more women and minorities to tech. One thing I think is really amazing about Angie is how creative she is and how she gets people into tech. So, you know, she volunteers, she writes, she gives talks. She's built this like huge education platform with talks by dozens of people that teaches you like how to get into testing. And like, I think for most people, all of that would be enough. But another thing she does is she has this side project called Diva Chicks that she's been working on since 2008, which is a competitive fashion game. So there are hundreds of thousands of members, and the players design digital clothing and their daily competitions to see who can make the best outfits. And I just think that's so incredible. I wanted to share that with you, that extra fact. So without further ado, let's go to Angie Jones' talk.
Hi, I'm Angie Jones. I'm the Senior Director of Developer Relations at Applitudes. Today I want to talk about coding future coders. There's very few things that I enjoy more than coding. Looking at a problem, opening a blank canvas, creating a solution to that problem, and then seeing it execute. The joy. How many fields are there where a large percentage of the professionals also do their jobs as a hobby? Many of us, we work on side projects, we work nights, we work weekends, we work holidays just for fun. It's almost inconceivable that people actually pay us to do this stuff. Remember when you first started? I'm sure a lot of you fondly recall the days of the Commodore 64 and typing your very first hello, only to discover that you needed to learn a new language to tinker with this thing. You learned some basic commands and were able to do a bit of math with it. And if you were really hardcore, you had a subscription to one of the magazines such as Compute, which provided type-in code for you to try out. While I grew up in the 80s, these are not my memories. I wasn't exposed to these things as a child. I didn't have a Commodore 64. I've never touched an issue of Compute Magazine. In fact, this was not something I'd ever heard of. I didn't find my joy of coding until I went off to college. I entered my freshman year very uncertain about what I wanted to do for a living. I chose business as my major because it seemed like a broad enough discipline to be applicable to whatever it is I did end up becoming. My father, he was an accountant, and he'd seen signs of technology becoming this emerging space. So he encouraged me to take a computer course just so that I knew how to use these things. Well, silly me, I enrolled in a C++ programming course. I know. I didn't know what programming was. I'd never heard the phrase C++, but college is all about exploration, right? So at the age of 18, I wrote my very first Hello World. I instantly became hooked. The thrill of crafting the commands to, magically make the computer do as I imagined. The power, right? And after each class, we'd get a homework assignment, and I remember racing to the computer lab to complete mine. I'd save it to a floppy disk, and I probably run this about 10 more times before it was actually due in a few days. And this was only because I couldn't get enough of seeing it run. My professor, he recognized the passion that I have for this and how good I seemed to be at it. And he asked me, why wasn't I a computer science major? And I explained to him that I don't know what that is. What is it that a computer scientist does? And this is what they do, he explained. So he encouraged me to change my major to computer science, and I must admit the thought of writing these fun programs for a living sounded really exciting. So finally, I'd found what I was meant to do. I got to wondering, is my story unique? Well, there's only one way to find out. I'm going to take you to my favorite research site, Twitter, to see when others learned how to code. So there was a tweet, and it asked, how old were you when you typed your first line of code? Brenton says that he was 7 years old, and he wrote a really simple ASCII art soccer game in BASIC one afternoon after school, second grade, no big deal. He said that his dad wrote Ninja Turtles game with him when he was much younger. So he started pretty early. Chris says that he was 10 years old, and he even remembers some of the commands here. Shane was 8, and he did logo on an Apple II. Gregory was 7, and he remembered also using BASIC, and he had one of those newspapers with the game instructions. Tom was also 8. He used QBasic, used it to say hello to you before playing a tune on the PC. Pretty cool. Frederick was about 10 years old. He remembers coding infinite alerts in JavaScript, and his dad had to quit the browser. Kevin, he was 10. Brian was 9. He had one of those books in the 80s, and he also remembers the, code along instructions, and he made a cool little shark fighting game. Ollie was 19. It was in her first computer science class. Taylor was 20. Christina was 20. Kara was 24, taught herself on Code Academy. Jen was 22. Carla was 28. And McLeanne was 51. That's pretty cool. So this got me to thinking, why was there such an age difference between when the males learned to code versus the females? Obviously, women enjoy coding, so how come they didn't start earlier? Well, let me take you on a quick trip back to the 80s so that we could see what exactly was going on back then.
When it comes to video games, nobody compares to Atari.
I find Intellivision more sophisticated and lifelike. Gentlemen, move over for my friend Vic. The Commodore VIC-20. Move over. The Commodore VIC-20 does more than your machines. It's a great computer that also plays great games. Like this, and this, and this.
A computer that plays great games?
Under $300. Exactly. We didn't know. Get the Commodore VIC-20 computer.
So what did you notice in that commercial? Well, there wasn't a single woman in there, and it seemed to be aimed at gaming, right? Okay, let's look at another one.
Some people have big plans after school. You know what Elliot's going to do? Jeff, too. Elliot's at work on a book report using Scripsit on Radio Shack's Color Computer 3. It hooks up to his TV. And Jeff's at his Radio Shack Color Computer 3 playing the newest football game. But wait, what's Elliot doing playing new Super Pitfall? And Jeff's having a blast with a new math tutor. You never know what you might try with more than 100 programs for fun and learning. Radio Shack's Color Computer 3 comes with everything you see here. Other items each sold separately. Only at Radio Shack.
So there were some girls in that one. We saw them get off the bus before and after Elliot and Jeff. Who knows what they were going to do, but we do know that Jeff and Elliot were going to their computers after school, right? And we even saw one of the boys' sister come over and kind of look over his shoulder to see what he was doing, as if she thought it was cool, but no way she would actually use the computer. Right? Let's watch another.
Using an Apple II is very easy. The only hard part is getting your kid away from it. You see, Apples are the leading computers in schools, so even though you bought it to help you work at home, your kid will want to use it for his own homework. Of course, if all else fails, there's one last thing you can try. Get him an Apple of his own.
So in this one, Dad, he brought the computer for himself, but his son was glued to it, right? The son was using it for schoolwork and for leisure. So it seems that it's for both work and hobby. And the other activities that Dad tried to get his son involved with, they just weren't appealing. Only the computer. That's all he wanted. Don't we see that with a lot of tech bros today, where, you know, they kind of expect everyone to live and breathe tech? Let's watch one more.
It's a Radio Shack Merry Christmas.
Well, I remember that Christmas. Dad gave me my first shortwave radio from Radio Shack. What memories. This Christmas, we got our son's Color Computer 3 from Radio Shack. It hooks right up to our TV and was on sale for less than $130. The Color Computer 3 makes learning fun. Jimmy even lets me use it for word processing when he isn't playing computer games. Lucky I still got my shortwave.
So this dad, he took such pride in getting his son this computer for Christmas. And he thought back on how special he felt when his dad got him a gadget when he was a kid, you know? And he wanted to do the same for his son. Now, we saw this not just in commercials, but we saw this same type of thing in print ads as well. There are women here, but only as eye candy, the prize, you know? Not interested in the computer, but the man who controls the computer. Cringeworthy, I know. Look at this one, also an ad. So this ad is actually pointing out that you need a computer for family needs. But there's no complete family shown here, right? It's only the boys that are shown in this picture. And in this one, we see a family The salesman, however, is pretty much focused on selling to that boy. He knows that's who's going to use this computer. Now, also looking at the body language here, looks like dad is in control. Even though the salesman is selling to the boy, dad is going to be the one that makes the decision. Mom is kind of off to the side, just happy that her boy is going to get his toy. And then they no longer implied it. They flat out said it. In this one, it says, what kind of man owns his own computer? Letting it be known that this is definitely something for men and boys. And here's another ad. This one is a wanted ad saying that there's a huge demand now for people not only to buy this, but to program these computers. Well, of course, we need men to do this, right? I highlighted a blurb from this ad that says you don't have to be a college man to get a good job in computer programming. Today, even high school grads are stepping into excellent jobs with big futures. This narrative was even prevalent in pop culture. So movies such as War Games glorified the hacker culture. There was Revenge of the Nerds. I like this movie, right? This one was where the nerds are cooler than the jocks and they're stealing their girls. There were movies like Weird Science where these techies were able to program their dream girl. Now, the power of marketing is not one to be underestimated. And there were some pretty strong messages in the 80s about who computers were for. Here are some of the quotes that I found about the power of marketing. It says, marketers have advertising down to a science. They research and they analyze consumer behavior. And we're conditioned from an early age to pay attention to the messages that marketers present to us. Very smart, creative, crafty people are tweaking your brain to get you to want something or to buy something. And while you might think that you're arriving at a conclusion completely on your own, I promise you, marketing played a role in some way. Marketing is so powerful that it can shape our values and beliefs. And we're often not even aware that it's happening. So, what were some of the subliminal messages that we saw in the marketing in the 80s around computers? Well, we saw that computers are toys for boys, smart boys, geeky boys, definitely boys. So, what were the consequences of this? Well, we just so happened to see a sharp decline in the number of women who were studying computer science right along this same time. NPR did a study to show this dip in the 80s where the other sciences, women were still going, kept going up for them, but computer science specifically had a sharp decline. And we never quite recovered from that. Those who did study CS, they felt out of place. They didn't have as much experience with computers. They didn't have stories to brag about. They didn't live, breathe, and sleep computers. And they didn't feel like they could ever catch up. So who do we blame for this? Do we blame the marketers of the 80s? Do we blame the guys who tinkered as boys? Do we blame the women for not getting involved sooner? No. We blame no one. this isn't about blame. This isn't a guilt trip. No one should feel bad if they were introduced to tech at a young age. That's beautiful. It's wonderful. But we're problem solvers by nature. And clearly we have a problem. One way to fix this is to introduce underrepresented children to tech earlier. So it pains me to think that there could be several others just like me who never heard about tech as a field, who never played or tinkered with computers as kids, who, never had those magazines. And thinking of them missing out on this wonderful, joyous career simply because they'd never heard of it kind of breaks my heart. So I set out to introduce young girls to tech, but I worked a full-time job as well. So I don't necessarily have the time to change the entire industry, at least not by myself. So I began to search for organizations that were already doing this type of work. And I found two, Black Girls Code and Tech Girls. And both of these organizations work to expose girls to hands-on coding projects. So Black Girls Code mission is to train 1 million Black girls how to code by 2040. And this group targets girls to between the ages of 7 and 17. And they put the girls into different classes based on their age. So there may be one for girls under 10, and then another one for girls ages 10 to 12, and then 13 and older. And this program was actually perfect for my schedule because they host an event like once a month or so on a weekend, right? So it'll usually be on a Saturday from maybe 10 a.m. to 4 p.m. But there are a variety of volunteer options available. So if you want to teach a class, which I did sometimes, you take an all-day shift, okay? But there's also an option to be a teacher's assistant where you can sign up for just a morning shift or an afternoon shift. So if I had an entire Saturday to volunteer, I teach. If not, I grab one of the shorter shifts. Also, this is a one-time commitment, right? I don't have to go every Saturday, just whenever I'd like to. If I'm in the mood, if I'm in town, if I have that day open, it's a wonderful way to give back. So this worked really well for me. And then Tech Girls is open to all girls who are in middle school. And research shows that this is right around the time when these girls start to lose interest in things like science and math, right? And based on the small sample of Twitter research that we reviewed, we see that this was a critical age for boys when exploring tech. So Tech Girls, they also do these periodic events, but there's usually about 3 hours or so, and theirs is typically on a weeknight. So this is also great for my schedule. If I didn't have a weekend to volunteer, then maybe I could do, a Tuesday evening after work or so. We teach the girls all kinds of fun things. For example, in this JavaScript workshop, we go into Chrome DevTools. We'd have the girls make little small programs, right? Starting with things as simple as an alert. If that's your first hello world and you make something pop up, that's pretty cool. And then we move on to variables. And by the end of that session, which again is only a couple of hours, by the end of that session, they have written a full program to maybe calculate the tip on a restaurant bill, and print that out to the console. So JavaScript is the language of the web. So for the girls to grab this skill at such an early age, imagine the doors that are opening for them. In this one, the girls create virtual chat boxes, and they program the computer to guess their inputs. AI is a hot space right now. So imagine the seed that we're planting by sparking their interest in this on one random Saturday, you know? We also taught them how to build a game using MIT App Inventor. And what's so great about these types of workshops is that we teach them, the fundamentals, and then we just allow them to explore and do stuff on their own. So they are able to come up with their own game, think it up, and then build it. And you'd be amazed by the creativity of these young girls. So we allowed those who wanted to demonstrate their games at the end of the workshop. And they do this in front of the other students as well as the parents who've come back. And I vividly remember a 7-year-old, and she was playing the game that she built in front of everyone, huge crowd. So she got in front of this. She wasn't nervous or anything. And as someone who has studied and built games myself, I was in awe seeing how she had all of the elements of a perfect game. She had engagement, she had addiction, she had just the right amount of a challenge. And I left there feeling so inspired. This young girl was clearly gifted, and maybe I played some small role in showing her a joyful avenue for her gift. We did another session with the girls with Python and Raspberry Pi, and we called this one the Parent Detector, which is basically a motion detector which records video when it senses movement in the room. So we had the girls connect the motion detector, write Python code to have the camera record upon sensing movement, and then save the recording to a file. And I remember when the girls came to this workshop. So it was after school, and they were kind of trickling in one by one. And the volunteers helped the first few girls get set up. And then I remember as the next wave of girls trickled in, without prompt, the girls who were already set up went over to assist the new girls and get them set up. And this had a domino effect with each group helping the newcomers. And I also remember that this workshop was a hit. So we had more girls show up than we had Raspberry Pis. And I remember the girls openly inviting others to pair with them. And let me tell you, this was the best pairing sessions I've ever seen. No one played the bad. No one, dominated. It was just genuine, natural, mutual learning together. Unfortunately, we don't hear a lot of women in tech describe their work environments in this way. And I think having them experience this as young girls will give them that untainted taste for tech that will hopefully encourage them to stay in the field even when things get a little rough. Now, when I talk about volunteering, I sometimes see a peak of interest on my colleagues' face, or they may even say, wow, that's a great thing that you're doing with the girls. But it doesn't necessarily dawn on them that they can help out too. So I started actively encouraging my male colleagues to volunteer as well. And they actually came. So here's another guy who came, one of my colleagues. And here's some more. And you know what? They had a great time helping the girls. So this is definitely something that, if you're a guy, you don't have to leave this to the few women who are in the space. You can help out too. Same goes for Black Girls Code, right? Even non-Black women weren't sure if they should help with Black Girls Code. But there's only so much that I can do and other Black women can do. So we definitely welcome all the help that we can get. And I invited the women out, some women that I worked with, and look at them front and center. They had an amazing time and, were able to give back. Now, I set out on this quest to spark the joy of coding in others, but I must admit, I always leave these workshops just so rejuvenated. Sharing my passion with them, seeing them light up and produce their own artifacts, returns a new joy to me. So that's my small contribution to the next generation. I hope that you'll also consider sharing your joy of coding with them as well. Thank you so much.
All right. We appreciate Angie being our keynote. I think her sharing the joy of programming with all these young kids is a perfect start to the conference for the joy, surprise, and excitement in computing. We have about 9 minutes before our next session starts. So grab a drink, go take care of anything you might need to do, and we'll see you back here shortly. All right. Hello, everyone. Welcome back. It's been a great Bang Bang Con so far, even though it's been pretty short. I would love to help kick us off into our next session of talks. My name is Sarah. I'm one of the organizers of Bang Bang Con. It's been amazing and wonderful to be a part of this process, as well as just see all the great talks that come in, working with all the speakers. And definitely, like, as I'm looking at Discord right now, just seeing all the wonderful joy that everybody's been having so far from our opening keynote. So keep that going for our next session of talks. Introducing our first speaker. Our first talk is Learning to Code with Doom. Now I'm even more confused. Phil Salvador is a librarian, digital archivist, and game historian who writes about unusual old computer games on his blog, The Obscuratory. But most importantly, he is a friend to all the birds. Please welcome Phil Salvador.
Hello. Thanks so much for having me. My name is Phil, and over the pandemic, I learned how to code. A friend of mine, right when the things were starting to, flare up, a friend of mine was working on a mod for the video game Doom, so I learned how to code to help him out. I figured this would be kind of a fun way to learn how to code, get my hands on with a little more coding experience. But it turns out that making a Doom mod in 2021 is actually a lot more complicated than you might think. It was a little more than I bargained for. And I want to explain why that is by talking a little bit about the engine that powers the Doom games. So when you think about Doom, Doom is a game that came out in 1993. But what happened shortly after that is a couple other spin-offs and games that use the Doom engine begin to come out. They start adding their own features. They start adding all these new scripting systems, things that people can use. At the same time, fans are also making their own hacked version of Doom where they can add new graphics and effects. So you get things like, the Simpsons Doom mods that come out around that time. And then also the Doom source code is released publicly. So fans begin to take all of these features, all these spin-offs, and they begin to incorporate them into new versions of the Doom engine. And they keep adding features and making spin-offs. And they keep stacking things on top and keep stacking things on top over and over and over until you get this teetering tower of dependencies that is the Doom engine. Just all these features just stacked atop each other. So, if you made a Doom mod back in the day, you really just had to learn one or two things. If you're making a Doom mod in the year 2021, you have to learn a modified version of C that is based on a custom bespoke programming language that is built on top of a series of spin-offs and hacks to a video game from 1993. And there's also a completely separate scripting language you have to learn how to use that has a different version of math. So it's kind of a mess. And I want to walk through, I get the sense that a lot of coding is like this. So I want to walk through one example I had to deal with where I learned how temperamental this stuff can be. And this is an example of trying to play one sound effect and everything that rippled out of that decision. So this is a very silly Doom mod my friend was making. So there was a feature I wanted to add to the mod called constant screaming mode, where you turn it on and the player character just screams constantly. It's very silly, but I thought this is a joke feature. I can, knock this out in like an hour. It'll be pretty easy to do. So this was the script I originally wrote. It's a pretty simple script for the player that says, if screaming mode is turned on, play the screaming sound effect. If screaming mode is turned off, don't play the screaming sound effect. But things got complicated pretty quickly because, again, of this giant tower of dependencies and other versions of Doom, and there's all these features that kind of conflict and collide and don't mesh well. So I want to talk about two of those features and how they ended up making this very simple script surprisingly complicated. So one of the things in this mod is, in addition to playing as the traditional human Doom character, there's also a part in the game where you turn into a tank. And we do this by using a feature that was introduced in one of the Doom spin-offs called the Morph system. This was added in the game Heretic, which was it uses the Doom engine. And it's a feature that lets one player character transform into another player character. It was originally used as sort of a joke. There was an item that turns you into a chicken in Heretic. So we're using it in ways it was really never intended to be used. And it doesn't play well with some of the other features that eventually got added to the Doom engine. And one of those big features is the way that gender is conceptualized in the Doom engine. This was something that was added by fans in 1998 in a fan version of the Doom engine called ZDoom. And it was meant to let players use custom pronouns in multiplayer mode. So, when you get blown up, it says player 1 killed herself, for instance. And I think this was, a fairly progressive feature for its time, but it has some pretty significant limitations. The biggest one is that the player's voice sound effects are tied directly to the gender they select, which is, somewhat an archaic understanding of how gender works, but it's what we have to work with when we're making a Doom mod. But the really weird part of this is that gender in the Doom engine is conceptualized as a scale of 0 to 3, which, sure. So here's the scale. The reason this is so weird is because players are the only characters in the game that actually get given genders based on the player's preferences. Everything else in the game gets a default gender value of 0, which, as you can see here, corresponds to male, which means that technically speaking, every object in the game that's not a player, we're talking every monster, every rocket launcher, every flaming barrel, is technically male. The reason this is a problem is because the morph system was designed before there was ever, gender in the Doom engine. So it doesn't account for it. When you turn it into a tank, it's considered a new character that's not technically the player, so therefore the tank is also considered male, so it's not going to play the correct sound effects. So I had to manually re-implement the gender system of the Doom engine. I had to manually rewrite it and attempt to read the player's preference file and then see what, choose which sound effect to play based on that. So this is already starting to get pretty far out of hand. This script is getting pretty long for what was originally supposed to be a joke feature. But we're not done yet. Of course, there's one other very frustrating thing. So we have to go back again to the morph system, because once again, we're using it in ways it was never intended to be used. It was a way to make the player turn into a chicken as a joke. We're using it as like a major feature of this game. So the issue is that when you transform with the morph system, what I learned is that technically the player doesn't actually transform. The player becomes intangible and invisible. A new character appears, and then you control the new character. So technically, there's two characters in the game world at once now. There's the human character, and there's the tank character. And the Doom engine doesn't distinguish between them. So now both these characters are screaming at the same time. This is not ideal. So we have to find some way to only make the correct character scream. And we turn to something that I understand is a very important part of any programmer skill set, which is terrible workarounds. What we end up doing is we're going to use the inventory system in the Doom engine, because for some reason, the inventory system does work with the morph system. Things do transfer between characters correctly. So we're going to horribly misuse this. We're going to, instead of having the player scream themselves, we're going to give them an item that screams. The item, if it's owned by a player, it will look at the player's options, see what gender they selected, and then scream in the correct gender. But then when they turn into a tank, that item is going to transfer correctly. So it's still only going to be one scream sound effect. It's moving over to the correct character. This is how we have to implement this. This is kind of ridiculous. So again, I started out with like a 6-line script, and by the end of this process, I've ended up with a script that is multiple pages long and spans across multiple files. It has to re-implement a chunk of the Doom engine into it in order to work correctly. So going into this project, I understood when people said like, oh, my code is so ugly. It's so, it's so full of hacks. Don't look at it. And I understood that in principle, but I don't think I actually was able to get what that meant until I did this, until I had to create this, terrible Frankenstein workaround to make this joke feature in the Doom engine work correctly. But it was a very interesting experience. I learned a lot about programming, having to see a very simple line of code slowly turn into this monstrosity. So the lessons I learned from this, the most important lesson was coding is a labyrinth of absurdities. I get the sense that a lot of coding is like this, that there's just these towers of dependencies and things you have to worry about affecting different levels and having to understand how the engine interprets what you've written. I get the sense that this is a lot of what coding is. But the thing is, I liked it. I really enjoyed this. I like the problem-solving aspects of it. I like the fact that you get this seemingly simple task, and to actually make it work, you have to start to understand how the engine works. You have to understand how it's interpreting your inputs, how different parts of the program are parsed by other parts of the program. I thought it was really interesting that it gave me a better sense of what the character of the Doom engine was. I think compared to any other game engine that exists, you really get a sense of how it's all these sort of interlocking systems, and how it's the decision to have strong backwards compatibility with old versions of Doom to incorporate legacy features to build on top of those features. And by having to learn how to do something like this, you get a better sense of what the Doom engine is and how it works, just kind of what the feel of this kind of, indeterminate feel of the Doom engine. I thought that was really cool and exciting. And that's what I think was interesting to me about this project and about programming in general. I get why folks enjoy this. I get why people enjoy programming. I like tinkering with these things. I like having to poke and prod at it and see why things work the way they do, even and especially when it gets confusing, because as I learned that day, it took me the larger part of an afternoon and an evening just to make my computer scream at me. Thanks for having me.
All right. Thank you, Phil. I appreciate that. I especially appreciate that you said coding is a labyrinth of absurdities, which all I can just think about is like that's a perfect tie into having a constant screaming mod on Doom. It's great. So thank you, Phil, for that. Our next speaker is Aaron A. Reed, giving a talk called From Oregon Trail to AI Dungeon, 50 Years of Text Games. Aaron is a writer and game designer and game historian focused on helping game makers and players tell stories together. He's a multi-time Indiecade and IGF finalist and has spoken about digital storytelling at venues as diverse as Google, PAX, GamerX, and Worldcon. Please welcome Aaron.
Hi, I'm Aaron A. Reed, and I'm in the middle of a year-long project about the history of games made with words. This December marks the 50th anniversary of the original text-only Oregon Trail game, and since there are about 50 weeks in a year, that gave me the idea to spend each one of them blogging about a single text game from 1971 to today, one game for each year. Now, when you hear text game, you might think of text adventures, but there have been all kinds of microgenres over the years that have used words instead of graphics to tell their stories. Of course, at first games were forced to rely on text because the earliest computers had very limited graphical capabilities. But rather than dying out when graphics took over, text games have wriggled and evolved their way into all kinds of corners of the gaming landscape. And without the spotlight of the mainstream, so many of these games have been free to experiment and innovate. Each of the games this series is looking at is a unique snapshot of the time and place it was made, a nexus of technical and cultural and economic and personal decisions. Many of these games are in danger of being lost or have been overlooked by newer generations of gamers, and I've been thrilled to make the case why each one is worth remembering. Now, choosing which games to cover has also been an interesting challenge. The conceit of covering just a single game from each year has meant I've had to skip over many classics, but it's also made me look more closely at understudied time periods and led me to discover a lot of hidden gems. The series hit 1989 just this week, so there's a lot more to come, but no shortage of fascinating stories to tell. In a 10-minute talk, I can't begin to do justice, so I'm just going to take you on a whirlwind tour picking one game from each decade that's maybe a little more on the obscure side to give you a taste of all the great stories in this weird little thread of gaming history. So let's start with the 70s, and the first company to succeed at selling games for personal computers, Adventure International. Not everyone's heard of them today, but for a few years they were the kings of computer gaming, racking up millions in sales, and they paved the way for the software giants of the 80s. The founders of both Sierra and Broderbund got their start working there. They even invented the first retail packaging for computer games, and yeah, they came on cassette tapes back then. Now, if you have heard of this company, you may think you know who wrote all their games. After all, it was his name on all the boxes. But if we look at the title screens for some of these games, we see another name, Scott's wife at the time, Alexis. So who was Alexis Adams? She was an entrepreneur who actually ran most of the business side of the company and also collaborated with Scott on some of the games, even teaching herself enough coding to write at least one of them herself. Scott credited much of the unique feel of Pirate Adventure, their second game, to her. It's one of the earliest text adventures where the player's main goal is building something, not collecting treasure or killing monsters. You're shipwrecked and you need to repair your boat. There's a pirate, but instead of trying to kill you or rob you like NPCs in earlier games, he basically just wants to get drunk and not have to do any work. At one point, you find him sleeping off a bender in a graveyard. Alexis had sole author credit on the 1979 game Voodoo Castle, again though only on the title screen. And this game, which is dedicated to all moms, has a character named after the Adams' daughter, Megan. This character is one of the first women in a computer game with dialogue. Scott and Alexis later divorced, and her part in the legacy of the company faded over time, but she was undoubtedly a huge part of the world's first successful computer game studio. Then there was the 1980s, the decade of Infocom's legendary interactive fiction. But let's fast forward through all that and talk instead about an even more obscure genre, play-by-mail gaming. In Monster Island, you play a castaway survivor on a dangerous continent. The game ran on a computer, but the players never touched one. Instead, they'd fill out a paper order form each week detailing their character's next moves and send it into the company through the mail, no software required. Once a week, you'd get back a turn report, a stack of laser-printed pages detailing the results of your orders. In Monster Island, thousands of players shared the same persistent virtual world, an enormous continent 3 times the size of Australia with over 250,000 individual locations. The game started out simple. The rulebook was just a tiny pamphlet that listed less than 20 orders. But as you kept exploring, the list of actions you knew how to do would grow. Reach a trading outpost and you'd learn orders for buying and selling goods. Stumble across another player and you'd learn orders for how to be friendly or hostile. You might even learn how to request and send in entirely different kinds of order cards. Years before wikis, players had to coordinate through letters and fanzines to figure out how the game they were playing even worked. And it was so huge that years after it launched, major portions of it, like an elaborate magic system, still remained largely mysterious. Play-by-mail gaming mostly died out in lockstep with the rise of email and the web, but a hardcore Monster Island fanbase continued playing the game for almost 30 years, an incredible run for a game its creator had hoped would last for 3. In the early 90s, a rather unusual game was released called Silverwolf. This obscure text adventure is about a group of shape-shifting women superheroes protecting an ordinary schoolgirl they believe is the reincarnation of a god. It was made by, and you're not going to believe this, a group of shape-shifting women really into schoolgirls and strange divinities. But let's back up. In the early 80s, St. Bride's School opened up on the remote Irish coast. It was a sort of fantasy camp where women could take on the roles of Victorian-era schoolgirls under the tutelage of a strict headmistress. There was no electricity, and modern materials like plastic were forbidden. But sort of inexplicably, in 1985, this group that shunned the modern world started making and selling computer games. Maybe as a publicity stunt to draw attention to the school, or maybe the school was a publicity stunt to draw attention to the games. It's unclear. In fact, many things about St. Bride's are unclear to this day because the women behind it deployed a baffling array of different names and personas. There may have been as many as 14 or as few as 2 distinct women behind them. And what they were really up to in that house in Ireland remains a puzzle. Some of them had once been involved with a group called Lux Madriana that worshipped a female god. Some of them were really into discipline. Whatever their true beliefs, Silverwolf was one of St. Bride's last games released, and it's filled with beautiful writing and enigmatic riddles. I especially love this description of a tree made of ice filled with the buzzing of silver bees. There's some suggestion its author may have been trans. If so, this makes Silverwolf one of the earliest queer games. The full story of St. Bride's is a wild rabbit hole. I haven't even mentioned the Atlantis cult, the Forbidden Door, or the connection to the 70s King Kong film, but I love how it gives the lie to the notion that the only people writing text games in the 20th century were bland hacker dudes. And now we've reached the 2000s, and this next one doesn't have any pictures because it was a game by and for the blind.
Proximity biodisruptor mine in 18 feet. East door in 9 feet. Manual bolt gun. Long knife. White data wafer taken. West, 30 by 50 feet. There is an exit from the room behind and to the left.
Shades of Doom is an audio-only first-person shooter. In a time before accessibility modes were common, blind or disabled gamers who wanted an action game had to build it themselves. Shades paints an audio soundscape with 3D positioned sound, which are loaded with useful information to help players navigate a maze of levels. Approach an intersection, for instance, and you can hear the sound of wind blowing down the side corridor. Your constant companion is Ava, the envirometric vector analyzer, a sort of screen reader for reality, who at the stroke of a key can describe the dimensions of rooms, the distance to walls or objects, and turn on a tracking device that helps pinpoint the location of moving monsters. EVA supports nearly 40 single-key commands, using almost every key on the keyboard, and learning to quickly deploy them is key to staying alive in a maze filled with zombies, mutant dogs, cyborgs, and traps like pits and jets of gas. Surviving the 9 levels of gameplay is a huge challenge, but one that's equally hard for blind and sighted players alike. Shades delivers fast-paced, tension-filled gameplay with only spoken words and positional audio, more than living up to its famous namesake. And finally, the 2010s. And actually, I'm going to cheat a bit and pick a game from the start of 2020. Sense and Semiosis is a lovely little text game about reminiscences triggered by bottles of perfume lovingly lingered over. As you read each description and the memories it triggers, you get to decide what they mean to you, what you want them to represent. It's a small game, it takes just a few minutes to play, but behind the scenes is an astonishing attention to detail in procedurally generating each delicate mood and description. Just before this game came out, AI Dungeon was getting a lot of attention for its promise of infinite stories from an artificial storyteller. Sense and Semiosis is precisely the opposite, a carefully sculpted and very human marriage of prose and systems to produce a handcrafted, joyful experience. It's also part of an unbroken thread of text game history, written at the end of the 2010s in an interactive story design language made in the 2000s, that evolved from a 90s language reverse engineering Infocom story format from the 80s, which originated in turn in the 70s with Zork. Some of Zork's technical DNA still lives in Sense and Semiosis today, and that's pretty cool. It's up for a Nebula Award for game writing this year alongside much more well-known titles, but I think it's beautiful that this delicate, handcrafted sculpture made from words and code is on that stage. So in the past half-century, text games have been everything from the mainstream to the underground and all kinds of weirdnesses in between. They've been made by all kinds of people with all kinds of things to say, explored countless ways that text can be fluid and stories reactive, and been a constant source of inspiration as small creators with unique visions have redefined what games made of words can do, mean, and be over and over again. If you want to follow along with the rest of the series, you can find it at if50.substack.com. Thank you for watching, and enjoy the rest of your Bang Bang Con.
Thank you, Aaron, for that great talk. I don't even know where to start. I feel like that, like so many things running through my mind, including like how I never thought going offline would be so interesting, but now I kind of want to run into a forest somewhere and make a video game with people that have no computer access. I
loved the audio only game. Like the idea that like as you approach the intersection, you start hearing wind. Like, man, I just had like so many ideas like popped into my head when that happened, which I'm sure they already implemented. But
yeah, there's a museum exhibit I went to once where it was complete dark. Like all the walls were painted. They had sealed off all the things so you couldn't see anywhere, and it was kind of fascinating. But just how you had to learn to navigate. And I love kind of this game is sort of interesting in a similar way.
All right, let's introduce our next speaker.
Yeah, so thank you, Aaron. You can reach out to him at Aaron A. Reed on Twitter, or jump in the channel on Discord. Our next speaker is Pokey Rule. Pokey is a freelance software engineer who will happily spend 3 weeks optimizing its coding setup to shave 10 seconds off a 5-minute task. He enjoys running, wild swimming, and crocheting various and sundry small animals while coding by voice. You can find him on Twitter at PokeyRule or in the Talon Slack workspace at Pokey. So Pokey is going to give us a talk called Cursorless. Keyboards and mice are so last year. Take it away.
Wrap arg odd with func flatten. Extract that as hello world. Nope 3 now drowse. Hi, my name's Pokey Rule, and today I'm going to be talking about what just happened. So let me start off by running that back by keyboard. Hopefully that'll be clear what I was doing. So I wanted to wrap this function call argument with the function call flatten. So I was a heavy Vim user by keyboard, so I think I do it relatively quickly by keyboard. So flatten. Okay, I wrapped it in a function call. And then I wanted to then go and extract that function call as a new variable. So let's grab that. Call it hello world, const hello world equals, and then I paste that. Okay, so let me try that again by voice. So let me put the cursor back where it was before, but it doesn't really matter because as you'll see, I don't actually use the cursor. Wrap arg odd with func flatten. Extract that as hello world. Drowse. So that's Cursorless, a tool that I developed on top of Talon and Visual Studio Code. But that's not where the story begins. The story begins in 2011 when I was diagnosed with repetitive strain injury from coding too much from when I was a little kid. It's what I absolutely love to do, and it was really devastating to be diagnosed with that and to think that I potentially wouldn't be able to code again. And it was a long journey from there. I got better, I got worse, I got better, I got worse. And until the beginning of this year, I discovered this amazing piece of software called Talon, which is a voice coding framework that allows you to basically define any commands and a grammar to do things, to completely control your computer, even coding. One of the challenges with Talon is navigating around a file. A lot of people use eye trackers, but for me, it's not really an option because I like to move around a lot. I like to stand, I sit, I pick up my laptop, I go somewhere else, and eye trackers don't work in those sort of scenarios. So I built this tool to quickly jump around the file. So I can give you a quick demo of that. So you see all these little hats on all of the tokens. So it picks one letter from each of the tokens and it decorates it, either with a hat with no color or a hat with the color. If there's no color, you don't have to say the color. So I'll show you an example of that. Let's say I wanted to jump here. I would basically say the name for E. Now I don't use E, I use a word each. And so every different letter has a different word. So W is whale, O is odd, etc. So I can say, take each, drowse. So drowse just puts it to sleep. Tells Talon to stop listening, and that click sound tells it to start listening. So it makes it easy for me to quickly go back and forth between talking to you and talking to Talon. So you can see I can say the color. So let's say this one I would say blue fine, right? So take blue fine, drowse. Okay. So that's how it started, a quick way to jump around the file. But then I had this realization, which was, if I can easily talk about any place within a file, why do I even need to move my cursor there at all? Why don't I just say what I want to have happen? So, for example, let's say I wanted to delete this. I can just say, chuck whale drowse. And you see it just gets deleted. My cursor never moved. It still has foo selected. So I can do all sorts of things. I can say square wrap look, drowse. So that puts squares around this thing, right? A bunch of these actions, delete, cut, copy, wrapping, all sorts of different things. So that was the first step. That was the second step, rather. Then the third was, okay, talking about single tokens is fairly useful, but it's not that useful because oftentimes you want to operate on bigger things than just tokens. So for example, this entire function call, right? If I wanted to grab that, I have a transformation, so which basically takes whatever it is that I'm talking about, and I can say, pick the function call containing it. So for example, take call air, drowse. So notice that took that entire function call, right? And there's all sorts of things I can do. So all sorts of different transformations that are defined. So if I wanted to delete this whole if statement, I could just say, chuck if air, drowse. So that deleted that. So that was the next step, right? So now I can do things where I can cut, copy whole sections, right? I could just take that function and grab it. And then the next step from there was, well, okay, so I have these hats. I kind of go full circle and back to the cursor. You know, it's called cursorless, but the cursor, there is something useful about having a cursor. So you don't need the cursor when you don't want it, but it can be useful to have the cursor. So for example, if I'm in an area, let's say, take trap, drowse. Okay, my cursor is here, right? So now I can use transformations. So for example, if I wanted to take this whole list, I could just say, take list drowse. So you can see, instead of saying one of the hats, I actually just don't say anything and it assumes I want the cursor. And one of the cool things about this is it works with multiple cursors. So for example, let's say we have this list again. I'm going to grab a few of these. Take whale and fine and gust. Drowse. Okay, now I have a few cursors, and now I can say square wrap arg. Nope. Square wrap element. Drowse. So you can see it looked at where the cursor was, and then it applied the transformation and the action to each of these different cursors. That's sort of the core of what a cursor list can do. It has these marks, which are these hats or cursors. It has transformations, which can modify each of these different things, and it's actions, which can alter whatever the target is. So let me give you a quick example of this in action. So let's say I wanted to take this list and turn it into a simple dictionary. So take every element, copy that, push, colgap, paste that, clear lack, lace, clear rack, race, chuck blue race, disc. So you can see I've now transformed that list into a dictionary. Drowse. I got to remember to put it to sleep. That's cursor list at a high level. I'm still actively developing features. I made a bunch of new ones in the past week, thanks to the motivation that a conference deadline was able to give me. But I'm still developing more. It's been an absolute blast. I've had so much fun building this thing, building all the different transformations, and then watching it all come together. And then as I'm building it, I can build it faster as I build more features. So I guess if I were going to close with a lesson or a message, it would be don't let anyone tell you that your challenges are disabilities. When I was diagnosed with repetitive strain injury, I thought I couldn't code and that I no longer had that ability. But now, without that, I never would have found voice coding, and I am now coding by voice oftentimes faster than I ever coded with a keyboard, and I have so much fun doing it. I feel like a wizard casting spells, which is just amazing. So thank you so much for listening. I hope you have a great day.
Okay, Pookie, that was great. Thank you very much for that. Hello again, Ernie. I'm fascinated at technologies like this because I remember seeing a MS Build talk once of a blind person, and he was using Visual Studio. And just as he talked, so many things were happening all over the place, and I loved the accessibility of it. But also just seeing this in action, kind of live, it's just really cool. Oh, you're muted, Ernie.
Yes, I am. One of my favorite things about Bang Bang Con is seeing all of the just like amazingly diverse ways in which people input code. I remember we had a talk a few years ago by someone who uses a screen reader who gave a demo during their talk. And then, of course, Pokey's talk right now. And it's just just the different ways in which people code is absolutely fantastic. And I love being able to share that through Bang Bang Con.
Yeah, definitely. And definitely fun to see just the many cool things like multiple cursors, like highlighting whole lists and copying and pasting them. It was really kind of cool. So
there were some people in the chat like discovering multiple cursors and like talking about it, which the more that people see how other people can code and learn those tricks and tools and things like that, I think it's just a really really neat thing.
Yeah, definitely. Thank you, Pokey, for that. We appreciate it. Our next speaker is Len Pepin, who will be giving the talk called Making a Pixely Circuit Design Language and then Building Circuits in It. Lynn is a software engineer, a data scientist, and a big fan of interpreted and interactive languages. During COVID times, they became enthusiastic about aromatic brewed beverages and about taking nature walks while sipping said beverages. They spend the rest of their time making digital art, video games, and poorly done crochet. I believe Lynn is here ready to give their talk.
Hey, sorry to interrupt, but we don't have any audio. There we go.
Can you hear me now?
Oh, we can hear you now. Go ahead and start.
Wonderful. Sorry about that. Hello. So just a heads up to anyone with photosensitive epilepsy, there are some strobing elements throughout this presentation. This is at 2 Hertz or less. So if that is something that might trigger your photosensitive epilepsy, you might want to sit this out or minimize the window for the next 10 minutes or so. With that said, this next slide and the following slides will have some strobing elements. So let us begin. So hello everybody, my name is Lynn, and as the title of the talk implies, I'm here to show you this little side project of mine that I've worked on for a while that lets you build a digital logic circuit in a bitmap image. The inputs and outputs of this language are bitmap images, and what you're looking at right now is actually a simple circuit inside of this language. So before I can show you much more about this language, I want to do a quick little refresher on digital logic circuits. So digital logic circuits, or Boolean operators as you might know them, are kind of the basic building blocks of circuits that we have. These 4 operators, AND, XOR, OR, and NOT, are kind of a basic mathematical toolbox that you can use when operating with bits or Booleans in programming, or with wires when making actual, little logic circuits. With this as our kind of toolbox, we can put these together and create memory cells. We can store data, do Boolean functions, and it's enough to make what we call Turing complete. This is really rad because you can build it up to create calculators, computers, any cool thing you might imagine. Now, when I was taking a digital logics course, I was also playing a lot of Minecraft. Minecraft has this feature called Redstone that also lets you make circuits, and it's also Turing complete. Kind of the intended purpose of Redstone in Minecraft is to create automated farms or automated doorways. And you can also create computers and calculators in it because, again, it's Turing complete. And people have done that. I highly recommend maybe you search it up on YouTube or something when you have free time because it's really cool what some people can do in it. But I was playing Minecraft, building my farm, and I thought to myself, hey, I have this little diagram that I'm working with as I debug my farm, but it'd be really useful if I could just run them. And I kept that idea in my head. I eventually finished that course, stopped playing Minecraft, and started getting really into, other programming languages. And I thought, hey, it'd be really cool if I could, continue with that idea. I want to be able to execute this bitmap image. And so I created what I call RISO. So what you're looking at here is actually the diagram the logo of RISO, and it's also a circuit inside the RISO language. You're looking at a circuit that's being executed, or an animation of a circuit that was executed. I'm not going to explain what every part of this is, and especially because during the stream, you probably can't see every element individually. If we zoom in, there's some elements here that are, very small to the eye. But there's an explanation of what's going on in the logo in the Git repository. But I want to show you now how to actually build circuits inside of this language. Re-implement those 4 gates that we saw. So I'm going to shrink the logo and go over the basic elements of this. So first, we want to be able to store and transmit logical values, ons or offs. And so there are wires. There's 3 colors of the wires: lime, sapphire, and orange, so that you can make a kind of colorful, pretty circuits, and also so that you can cross them diagonally. Because see, if a blue wire and an orange wire touch one another, if a blue wire and a blue wire touch one another, then that'll just be one wire, and you can't have that. They're not insulated, but they are insulated from one another when they cross diagonally. We also need logic. So we have dark and light teal for logical and logical XOR, and this is enough for us. And I have a fan going. Let me turn that off. Logical and logical XOR, but while this circuit diagram will have logic flowing from left to right, we still need a way in general to define directionality, inputs and outputs. So we add 2 more colors to our palette, dark and light purple for input and output. So we have these 2 gates here, and we're finally able to actually put things into our logic gates, which is really great. And you'll see the inputs and outputs. For example, the AND gate, if you look, you'll notice that when all the 3 inputs are on, bright, the AND output is on 1 time step later. That means timing is really difficult and you have to work with it, which we'll see later on. You can also use these to implement the other 2 logic gates that we want, NOT and OR. For NOT, you just put an input and an output next to one another. And for OR, you put an input and output next to one another. For NOT, you put an ON input straight into the input to an XOR, and then you can use the XOR as a NOT gate by just adding 1 more input to that. So there's one big problem here that I haven't been able to solve yet, is that Riso is not super accessible. If you're colorblind or you have any vision problems, this might be really difficult. And even if you aren't colorblind, a problem I had was that the logical and the lime wires are too similar in terms of color to one another on some monitors. So that's something I'm still trying to fix. Earlier versions of this had a textual representation of the circuit that would make it, easier to use in, whatever text editor to use. I haven't re-implemented that yet. But some of the original goals with Riso have still kind of followed through. I kind of wanted to be like Python in that it's kind of simple enough. It's kind of like an executed pseudocode, or in this case, diagram or sketch. And I also wanted to be like C in that the syntax of the language is kind of small enough to fit in one's head. If you've worked with C for maybe a year, you might remember almost every nook and cranny of the language, short of actually being able to write machine code, and even then. Because all the other digital logic tools I worked with, while way more useful and much faster than this, were kind of a pain to use. Now, this is also a pain, but I have an excuse that I'm not selling this for profit. Now, I want to, now that we see these 4 gates, we have our toolbox, and I want to show you a game of life circuit that I tried to make. Now, if you haven't seen Game of Life before, Conway's Game of Life, I should say, it looks kind of like this. You have all these cells that you can set up, and it's kind of this cellular automata that's meant to simulate what maybe a petri dish might look like. There's this one thing that's kind of iconic in Conway's Game of Life, a digital glider, or just a glider, that does this kind of thing. It repeats in a pattern of sliding downwards and to the right. Now, this here is not my project. This is copy.sh/life's implementation of Conway's Game of Life. Definitely go check out Game of Life if you've not seen it before. But back to this. I learned when making this Game of Life circuit that, again, didn't work. That timing is really important and it's really hard to do. To repeat, the goal was to create this kind of glider that went down the screen. That was my what I really wanted to see, and I couldn't get it done in time for Bang Bang Con because it was really hard, but I think the end result was really pretty. What you're looking at here is a 16:9 grid of Game of Life cells. If we zoom in, we can see some of the detail in the circuits. Here I have adders around the periphery of each cell that bundle together to the more complicated Game of Life logic. Now, there's some problems here that I haven't been able to bang out. This is the kind of the later iterations aren't shown here, so you might actually spot some problems, say in the SR latch. If you've seen these before, you know that both of these lines aren't supposed to be on at once. But if I show you the execution, and this is the part that has strobing at the full screen at 1 Hertz. If we show the execution, you'll see immediately things that aren't supposed to happen in Conway's Game of Life. We're not supposed to have everything disappear, then come back, and then flash like this. But this was really satisfying for me to see the values push forward through each gate, or each wire, just seeing them passed along. Now, thankfully, unlike my digital logic course, I will not be getting a grade from Bang Bang Con for the quality of my circuits. And when everything flashes on and off like it's not supposed to do, I don't have to feel too much anxiety about failing a class. At any rate, that's all I have for you here today. If you want to see the source code, I have a link to the GitLab and Emir on GitHub. If you have any questions or anything you want to ask me, feel free to contact me on Discord. I have the Discord here, but I haven't looked too closely at it for questions. So if you ask me, actually, I don't think I have time to answer questions during the presentation, so I'll be in the Discord. I'm also, you can contact me on Twitter as well. And also, if you make anything in this, I would really, really love to see that. I think that would be awesome. And that is all I have for you today. Thank you so much for watching, and I hope you have a great rest of your Bang Bang Con 2021. Bye-bye.
All right. Thank you, Len. I really appreciate that. I took a digital circuitry class in college as well, and we built a 4-bit calculator from logic gates, like down to the root level. Absolutely loved it. It was really cool to see this version of this talk as well, especially in a digital sense. Like, we don't actually have to have the real physical logic gates to do this. It was cool to see it in sort of a digitally represented form of digital logic gates.
I really liked that there was a Bang Bang Con logo that was blinking at the end. There's like a little,
of course.
Yeah.
Of course. The more Bang Bang Con's logos, the better.
Yeah, exactly. Yeah.
All right.
Oh, yeah, go. Sorry. Well, I think am I wrong that it is time for a break?
It is about time for a break. So
Okay.
first, thanks, Lynn. Again, lynn.pie is a Twitter handle if you want to reach out to them. Up next, I believe we have Julia, who's going to tell us a little bit about how the hallway track will work. So first, we'll have a break, and then we'll do our hallway track at the top of the hour. So if Julia's here, we could bring her on. Hello, Julia.
You're here.
You're here. Can we hear you? Can you hear us? Maybe not.
Maybe not.
Okay.
Okay.
We can try and ping on Discord or something, I guess, to make. Oh no, the computer crashed. Okay.
Oh no.
We can briefly try and talk about it before we get Julia back in. So we're doing a little bit different. There's a program called Skittish. So it's kind of a virtual environment that you can be a little animal character. You can explore around, walk around. I wish I had it up already, but I didn't. And it lets you interact with people. So it's a spatial thing. So as you approach another person, you can actually talk to them and they can hear you. As you back away, they can't hear you anymore. So it's kind of a cool environment to play around with. And we're going to be able to be not just like use it for the first time for Bang Bang Con, but actually be one of the first people that gets to use this product. It's pretty new. So I think it'll be pretty great to be able to try that out. If you have a ticket, you should have gotten in the email a link to the Skittish as well as the password you'll need to get in. So you can jump in around that. And I think we'll have it open for most like around the edges of the conference as well.
Oh, there's Julia.
There's Julia. Welcome back.
Hello. My computer crashed. I think I caught it from Ernie.
I know. Yeah.
Computers are
crossed.
difficult.
Yeah.
and I don't think I can share my screen on iPad.
Okay.
Oh, possibly not. But we tried to talk briefly, but if you want to give a better explanation.
Yeah. I really wanted to screen share. And
Joshua is saying that maybe he can do it.
Yeah.
Cindy, can we bring Joshua in here if he's hello?
Uh-oh. Hi.
You're on.
Live skittish com event. Wait, I shouldn't say the password out loud.
Don't say yeah.
Probably not. No.
Yeah.
One thing.
If you're in the Discord, the password is in the announcements channel.
Okay. I was about to ask. The other thing that
it is also in the skittish channel.
Yes, I was going to
Okay.
say we have a skittish
It's
channel,
everywhere.
which includes, I believe, the founder of Skittish. So if you have any
Yes.
questions or feedback,
Yes, Andy is there. Okay, joining, it says. Okay. Do not, I hope I'm not sharing my, oh, mic not found. Well, right, because two apps can't, oh, maybe, well, I don't know. All right, well, something interesting is about to happen to me. Okay, I think I'm in Skittish. Okay, let me share screen. Share screen, yes, correct. This is well rehearsed. This is heavily rehearsed. Yeah, share
Part
that.
of the
Share
fun
that.
of
Okay.
organizing a conference is like the odds and ends that we have to make up as we go along.
Okay,
oh,
amazing.
there you are.
Okay, I
what
think I'm
animal are
sharing
you
my
there?
screen. I have absolutely no
we get
idea.
to do the whole setup with you. This is so exciting. So now you have to click save. Well, you can
Okay.
pick your animal, and then you can do save once
Oh,
you've selected
with the
animal you
arrows.
can be.
Uh-huh.
Cool.
There are many people around it seems.
There are many people around. You can move either with the arrow keys or by clicking on where you want to go. Clicking is faster. Like clicking will cause you to move faster than the arrow keys will. It's good to use. So we should talk about the spatial audio. So you can't see it right now because I guess we're talking and there's all these people. But if you move close to someone, you can hear them, and then if you go far away, you won't be able to hear them.
Right.
So like how well you can hear someone depends on how close you are to them.
Yep.
Should we go to another room? Let's go
I was
to
going
the
to say
picnic area.
somebody just went through a door and
The picnic area is
disappeared.
to your left.
Okay. My laptop is lagging quite badly right now because it is trying to screen share and do Skittish at the same time.
Yeah, it's a lot.
Yeah. But we have
okay,
different
I'm gonna enter
spaces.
room.
You can go through the doors, and if we can show that, you can kind of explore different areas.
Yeah.
Yeah.
Oh, there is a dance party happening. Uh-oh. I don't know if you can hear if everyone can hear
Looks
it.
like
but,
we have some awesome 90s dance hits right now.
Oh, there's definitely a dance party happening right now.
All right, what's our timeline for all of this?
You can,
It officially starts in about 8 minutes, but several people are already in, so that's great.
Yeah, you can join anytime and chat with people. There's a Skittish channel in Discord for questions. Skittish is a very new platform, so there are definitely going to be problems. We're one of the first conferences to use it. So we would love to hear about all the problems in the Skittish channel, and we'll try to fix whatever we can.
Also, we want to hear about if you love it. Like that would be good too.
Also, just how things are going with it. And we can also make some changes just to the layout of the space. So if you have ideas for how the space could be laid out differently, we can change it.
Cool.
All right. Thank you for jumping in, Julia and Joshua. Appreciate that. So we're about to have a break. In about 7 minutes, we'll officially start the hallway track, but you're welcome to join a little bit earlier. Look out for some Easter eggs in this space. I think we've planned in some cute little things in there. At 6 p.m. Eastern, we will start our next session. So I think the stream may end, but just rejoin back or refresh the website and we'll start the new stream back up then. So for
Or
now,
as I call it, 3 p.m.
Yeah.
Yes.
Wherever you are,
I meant to
whatever
write
time it
down
is.
all the time zones, but I didn't get that far. So yes, 3 p.m. Pacific, 6 p.m. Eastern. And see you soon for our next set of sessions. Bye for now.